Okay, this would be the worksheet for 1B in the Math 4 course. And we're going to look at these problems. Problem 1, we're supposed to give a sketch of the problem and then find the requested features down below. F of x equals 3. You might as well think of that, and I always learned that f of x and y were interchangeable. To say that f of x equals 3 and to say that y equals 3 are basically saying the same thing on the graph. It's just that one is in function notation and one is in more algebraic. But y equals 3 is going to be a horizontal line where y is 3. And likewise, if you said x was 2, then you would have a vertical line going through where x is 2. Now, if we draw that line again, we have a domain that goes on forever. We have a range that is only 3, never goes up, never goes down. It does not have any x-intercepts. It has only one y-intercept, where y is 3. And then going down here, again, the graph right there. The relative local min, well, the minimum and the maximum are all going to be the same thing here. They're all going to be 0, 3. Well, I guess there's going to be a number of ordered pairs that would fit this description, but the minimum and the maximum will always turn out to be where y is 3, where the y value is 3. Normally we would try and put ordered pairs where we can, but here everything that has y for a 3, every single ordered pair would count, so we're just going to leave it that way. Now, for increasing and decreasing, when you think about it, at no point on that line is it either increasing or decreasing. There's no place on it where it's negative because it's above the x-axis. And so positively, when you go from negative infinity to positive infinity, it is all positive. And the endpoint behavior would be that as x approaches negative infinity, y approaches 3. And as x approaches positive infinity, y approaches 3. Okay. Now, f of x equals x is going to look like this. Straight diagonal through the origin with a slope of 1. And then we're going to go through and find all of these features. That was a little rougher, but it goes through the origin. The domain is going to be all real numbers, and the range is going to be all real numbers. The x-intercept is going to be at 0, 0, and so is the y-intercept going to be at 0, 0. When we start talking about maxes and mins, there's not really going to be a local min or a local max, because the absolute minimum is going to be negative infinity and the absolute maximum is going to be positive infinity. And there's no place along the way that it stops for a bump or valley. So there's not really any local maxes or mins. Now, looking at increasing and decreasing, it is all about the increase. So it's going to be increasing from where x is negative infinity to positive infinity. There is no decreasing. Right here is the spot where it makes the transition from positive to negative. And so the negative is going to be everything from negative infinity up to 0, but 0 has a y value of 0, which means it's not negative. So we put a parenthesis there. And likewise, on the positive side, it goes from 0 to positive infinity. Again, 0 is not technically included in either one of those, so I don't have any brackets. And then the endpoint behavior, as x approaches negative infinity, y is going to approach negative infinity. And as x approaches positive infinity, then y is going to approach positive infinity. As x goes down, y goes down. As x goes up, y goes up. All right, time to change functions here. Now, I'm going to give you a really, really cool tip here, if you will pay attention long enough to catch this. And that is, we're doing your standard function of y equals x squared. Now, I'm going to show you a little trick for a standard parent function parabola, is that you start from the origin and you go out one, up one, and on the other side, out one, up one. And then you go back to the beginning and you say out 2, up 4. Come back to the beginning, out 2 this way, up 4. And what's happening here is that 1 squared is 1, 2 squared is 4. So if I were to go out 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'd wind up here. And again, out 3 this way, I'd wind up 9 there. And so, but honestly, these 5 points right here are enough to give you something to work with. Please try not to make it look like a V. Please try to have some kind of curve to it. V's are for absolute values. But that is the trick that I like to show. Out 1, up 1, out 2, up 4, and you repeat the same process on the other side. Actually, this kind of thinking will also help you on the square root curve. We'll come back to this. Square root curve plays the same kind of game. All right, so here I'm going to do that and that. 1, 2, 3, 4, and that, and that. Okay. All right, the domain goes forever in both directions x, but the range stops here where y is 0. It goes forever positive, but it stops at 0, and it does include 0. So our x-intercept is going to be 0, 0. And for that matter, so is our y-intercept. Okay. All right. And again, dot, 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 dot. And we can make our little parabola here. After a while, the pattern gets kind of easy to follow. All right, relative min. And this is a case where your relative min and your absolute min are going to be the same thing. That's going to be 0, 0. Because it can be a relative min and an absolute at the same time, just like it can be a relative max and an absolute max at the same time. But the thing is that we have, well, our absolute max is going to be infinity. And so I guess from that perspective, you don't really have a relative min. this rule kind of qualifies if you have a point you can actually point to. But if it goes on forever, then there's no relative about it whatsoever. It's all absolute. All right, and once again, bing, bang, boom, bang, boom. Okay, it is increasing from, this is where we'll change colors. We've got negative infinity, we've got 0, and we've got positive infinity. Remember that while we're watching what y is doing, we are writing it, the answer, in terms of x. So from negative infinity to 0, it's going down. And from 0 to positive infinity, it's going up. Of course, at 0 itself, it's going neither up nor down, so there are no brackets here. Now, as far as the negative is concerned, everything is above the x-axis, well, except for the origin. So the negative, there is none. And for the positive, it's going to go up to 0, and then take a break, and then pick up on the other side of 0. And so the endpoint behavior, this is going to be a little bit more of a traditional response. As x approaches negative infinity, it goes to the left. Y is going up. And as x is going toward positive infinity, y is also going up. It's going up in both cases. All right, now I'm going to pause here and pick up the other problems in the next video.